In this problem, we are asked to use the given information about a country in the United States of Icelandia with height measurements of 10-year-old children that are approximately normally distributed with a mean of 56 inches and a standard deviation of 2.7 inches. Now, first of all, we have a normal distribution that is not standard because the mean is not 0 and the standard deviation is not 1. However, you can take the x value that's given and the mean and the standard deviation and find out where it falls on the z-curve. So first, I'll just take some information given so far. The mean is 56. I'm gathering that from right here. The standard deviation is 2.7. And then in part A, it says, what is the probability that a randomly chosen child has a height less than 56.6 inches? So this is our x, the 56.6 inches. And I don't know why I can't write on that. I guess it's because I froze my panes. But I really wanted to be able to do that. So I'm going to write that somewhere else. I'm going to write x equals x. I guess it won't let me. Hold on. Okay, now I should be able to draw. So x is 56.5 inches. And let's go ahead and use a different color for that. How about green? Okay, so x is 56.5 inches. So where does 56.65 inches fall on the z-scale? In other words, how many standard deviations is that from the mean? So convert it to a z-score. We're going to take x minus mu divided by the standard deviation. So 56.65 minus the mean of 56 and the standard deviation of 2.7. And so this will give us a z-score of 56.65 minus 56 divided by 2.7, and this should be a point here. Okay, now I'm going to find out what the z-score is for that x value. So the x value falls right around here. So this would be your 56.65 location. And if you draw a boundary up to the top of the curve and shade, because it says less, we shade to the left. This is the area we are looking for, which represents the probability. That is the answer to our question. And so we can just use norm.dist for this with 56.65, the mean of 56, and the standard deviation of 2.7. And of course, true for cumulative or the number 1. So that will get us the answer. Also, we could do it with norm.dist on the z-score of 0.24074, the mean of 0, standard deviation of 1, since we converted that to a z-score. So either one of these will give us the probability that x is less than 56.65. All right, so either of these approaches would work with using technology. You can also use the z-score table and just look up a z-score of 0.24 and get the probability to the left of it that way. So I'm going to use norm.dist on 56.65 with a mean of 56, standard deviation of 2.7, and 1 for cumulative. And I'm getting kind of a weird answer. Oh, because I entered my mean incorrectly. Okay, now that is an answer that makes sense. So now I have 0.595 as my answer to part A. And it says to round to 3 decimal places, so I would do that. All right, now the next part of it, part B, says what is the probability that a randomly chosen child has a height of more than 55.7 inches? Okay, now same thing basically, but I'm going to explain it a little differently this time. Instead of finding a z-score, I'm just going to put the mean 56.65 and, oh no, I'm sorry, the mean was just 56. And 56 point, what is it this time? They want us to use 55.7 this time as our x value. So that's just below. And this time we want the area to the right. Well, if we use norm.dist, that'll get us the left side. And then to get the right area, we're going to use 1 minus whatever we got from norm.dist. So mean of 56, standard deviation of 2.7, and 1 for cumulative. And that's it. That's all you got to do for this one.